Hi guys, welcome to our live stream. This is Howard, the Open Next Group. I'm your host today. I'm very glad to join me here. Now it's 9 Indian time, and I'm right in our Shanghai factory, which is about 25 minutes from Hongkong Airport. Hi guys, welcome. Okay, so today's protocol is automated fastener inspection, or you may call it optical sorting machine. The application and some answers to SOQ, frequently asked questions. I will answer some frequently asked questions. First, um, we can discuss why quality is important, why we should inspect it, we should check each piece of the fasteners, the bolts, the nuts, the screws. There is a case. The one plane of British Airways in year 1990, on July 13th, the, one plane of British Airways was jumping above the earth about uh, 10, about 10,000 meters, 10,000 meters above the earth in the air, and suddenly the window screen blew off, and uh, the pilots started out from the cockpit. The reason why this happened, because after investigation they found that there are 84, there are 90 bolts, there are 90 bolts to screw the window frame, but 84, 84 of this out of 90 bolts are undersized. In other words, the 84 bolts are shorter than the correct one, only 2.5 millimeters shorter. It's very tiny difference, only 2.5 millimeters, but they very small, very tiny defect, very small problem cause big trouble. Small defect cause big trouble. Okay, so you can see it's very important to guarantee, to make sure the quality of the bolts, the fasteners are good. Okay, so how to achieve? We should inspect them before. I think it's so crucial that we should inspect each piece before packing, before delivery. But how to approve, how to handle it, how to do this work? One, in traditionally, the fastener manufacturers will measure the dimension and will check the quality, the appearance by my eyes, by operators. But the problem is that first, they cannot make 100% inspection because there are so many dimensions in our fastener, in our boat. So they they only make temporary inspection. They only maybe select 1% or 2% of the total production run and measure the dimension, the critical dimension, maybe by the caliper, vernier caliper, by the thread micrometers, and maybe by the go and no go gauges, and or maybe projectors. Okay, for this method, it should be this machine, this memory tools are manipulated by humans, by operators. So the 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 speed is very low, and they cannot achieve 100% inspection. They make simply inspection plan, and there is a risk that they slip through the defective ones. The defective ones are not inspected, and they may deliver to the end user and may cause big trouble. Okay, that is one. Uh, that is very that will become our problem. Okay. Another problem is that it's very time consuming to check the quality by human eyes. Very time consuming. Okay. So it's a very time consuming. And besides that, the operators they judge the quality, the appearance quality of a partner. Uh, the judgment is usually inconsistent and subjective. They think it's good this time, the next time they think it's bad. The result is that there's no guarantee of 100% good quality. So that's why we should introduce the machine, the automatic machine, to do this work, to make the inspection, to check the quality of the parts. The quality is very important in modern industries because the competition is very severe. More and more manufacturers produce the same parts, produce similar parts, similar products. If your quality is better, you will win. If your quality is inferior, you will lose. Quality is so important that without quality, there is no survival. So uh, that's why more and more companies introduced our fastener inspection machine as shown below here. To start, I would let me please allow me to introduce the structure of our fastener inspection machine. Okay. Okay. Here you can see the machine. Our machine is made of two parts. The main body and the feeder. This is the main body. Yes, the main body of the machine is protected by the steel, by the steel shell, cabinet, like this. They call it's cabinet. It's a chamber. So it's a chamber. Okay, and they welcome to our live stream. This is your host, Howard, and I'm glad you can join me here. Okay, and here is a feeder. It's a vibrating ball feeder. It's used to feed, to orientate, to vibrate the parts, and it will convey the parts to the main body of the machine, to the work table of the machine, and then they can make the inspection. Our system can make the inspection Okay, and there's inner feeder. Inner feeder is served as a bridge. It also will vibrate during the process. During the process, it will vibrate. It will conceal the parts, serve as a bridge. It will conceal the parts from the vibrating feeder to the work table or the machine. Okay, now open the door of the camera. First, the part concealed through the inner feeder. It will be transported to the rotating disc. Rotating disc is made of high transparency, high transmittance glass. We call it glass cell. Glass cell is like a very big disc. The diameter of this one is about 50 or about 500 millimeters. The diameter of this one is 500 millimeters. But we can also make big ones. Maybe the part is bigger, but maybe the structure of the part is complicated. In that case, we may need more workstation. So we may need larger glass cell. Maybe we can choose. We may adopt a glass cell with diameter of 600 millimeters or even 800 millimeters. Our machines are highly customized. We can uh, tailor make according to your requirements. We can adjust it. We can modify it as you require. Okay. So the part on the glass cell will stand properly. It will stand properly. It will stand properly. After that, there's a first setting that. So there's a glass cell. Sorry, there's a steel wheel at the bottom of the mechanism. The steel wheel is on the top of the glass cell. No touch. There is no touch. Only a few millimeters above, a few millimeters above the surface of the glass cell. So there's no touch. So there's no touch. The part on the glass cell will be pushed, will be adjusted to the right position on the glass cell, to the right side of the glass cell. So they can be inspected after that. Okay? After that, there's a sensor. There's another measuring lab and the meter are fixed by this measuring lab. The sensor serves as a receptionist, or you may call it a lookout. It will give a signal to the system. It will tell the system that a part is coming. The product should be inspected, should be please get ready to inspect this part. The sensor can also count the number, can count how many parts are passed, so how many parts are inspected. After that, the first workstation for inspection, there and the inspection one. This one, the camera is placed at the top. So the camera is above, right above the part to be inspected. It will get the top view of the part. There are two light sources. One placed at the bottom and the one placed at the top. It will manifest the image. So the system can see very clearly. Okay, after that, it comes to the second station. This is two. Here, the camera is placed at the bottom. It's very big camera. It will get the bottom view. It will take the bottom, the quality of the bottom of the part. Okay, after that, come to the third station for inspection. This is display. This is way. Here you can see the part, the camera is placed at the corner inside the chamber. The camera will get the image, the side view here. It can get the total length, the height, total length of the screw, the height of the head, and so on. It can get the side view, and it can measure the measure the dimensions from this direction. Okay, after that, we come to the fourth, CCD4. Here the camera is placed at the bottom. It will get the bottom view, also get the bottom view, but it will check different items to different items to the second workstation. Okay, after that, we'll come to the fifth workstation. This workstation is quite unique because there are four cameras, four lenses, four prisms are placed in one workstation. The, the cameras are placed at the four directions of the path. It will get images from four directions. So there's no dark corner. There's no hidden area of the square of the screw. All around the screws will be inspected. We call it 360 degree 360 degree contour inspection. Okay, so there are five workstations and eight cameras. It will check the all around the cameras and measure the critical dimension. So after that, any defect will be observed, any imperfection will be found. So after that, we'll collect the parts according to their quality. If there is no imperfection found on the on the part, or there's no the dimensions are within tolerance, these parts will be just as good ones. They will be collected in the first discharge port. First order, we call it OK part, OK, OK port, OK port, OK collectivity through the first discharge port. Then after that, we'll come to the second discharge port. Second outlet, we call it NG path, because these parts are imperfection. There are maybe the parts there are some imperfection of the appearance. Maybe there's some imperfection, or maybe the dimensions outside. In that case, we'll judge it as defect one. So we'll remove it. We'll judge it as defect one, and they will be collected by the second collection beam, NG path. Okay. Then there's a third discharge port or outlet. Why we need a third discharge port? Because besides, why we need a third discharge port? What are the third group of parts besides good ones and NG ones? Because there's some uncentered in some cases, in some circumstances. In some circumstances, there is an emergency, and the emergency button are pushed, so the power cut off suddenly. The power are shut down suddenly. So we are not centered. The parts remain on the glass cell is good or bad. We are uncentered. The quality of these parts are uncentered. How to deal with this kind of uncertainty? We'll collect them by the third discharge port. The test discharge port. These parts will be tested again when we start the machine again. These parts will be powered to the to the feeder, to the vibrate bound feeder, and we'll check, we'll inspect the quality once again when we start the machine. Yes, that is we test. Okay, so now you can see the structure of the car, the structure of our machine, and the function of each workstation. So if you have any question, please comment down here, and I will reply you immediately. Okay, thank you. Hi guys, this is our live stream, and I'm your host, Howard. Right now, I'm in our Shanghai factory. Our Shanghai factory is about 25 minutes from Hongqiao Airport. And also, we are near the, I say, we are located, we are located in the Shanghai Jiao Tong University High Tech Park. So we are we are we are certified high tech enterprise. We have a strong R&D team with many experienced engineers. So we have developed hundreds of this kind of inspection machines. So we have many experience, a lot of experience in this area. Please trust us, and we'll provide you not only a machine, we'll provide you a whole solution to improve your quality and to reduce your manufacturing cost at the same time. Okay? So this is our last stream. Last stream in Shanghai. And our last stream will last about 5 minutes, about 20 minutes. If you have any questions, please comment down here. Thank you. Okay, now I will introduce the structure of the machine. So somebody wants to know how the machine actually works. Now I will show you. I will let the machine here. As the proverb says, seeing is believing. Please follow me. We see this part. This is the part where will be inspected. It's a very small screw with socket head. It's a cap screw with socket head, which will accept an Allen key. Very small, very small screw. I think it's very difficult to observe the imperfection on the surface of the screw. It's very small, very tiny part, very tiny part. Sorry, it seems the machine is still under developing. So let's go to next stage. What are the parts can be inspected on our machine? Okay, I'll make a brief introduction. What are the parts can be inspected by our machine? First, this one. bolts, 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 all kinds of bolts. Uh, like uh, French bolt, carriage bolt, slow bolt. Some bolts with headless bolts, we call it stud or six screws. Okay, and made of all kinds of all kinds of materials, carbon steel, stainless steel, stainless steel, copper, brass, or even iron. Yes, and aluminum. We can inspect it nearly all kinds of bolts, and the surface finish may be zinc plating, galvanizing, zinc plating, nickel plating, the tin plating, yes, and some special like diplomate, it's for special coating, diplomate, anodizing, anodizing. Okay, this is made of the carbon steel. This is bolt with socket head here, socket head, and which will accept an Allen key. Uh, okay, socket uh, socket head with Allen key, made of carbon steel, and the surface is zinc plating. This is a flanged bolt, hex head, also a flanged head, made of copper. Material is copper, pure copper. This is quite unique, special. It's a quite special uh, screw. We call it step screw, or we call it stem screw. It's an assembly of one machine screw and two washers, one spring washer, one flex washer. Stem screw, SEM, or somebody call it stem screw. Not only simple parts like a screw, but and simply complicated parts like stem screws, assembly of several small parts. Okay, besides that, this one hex nut. This is a nut. Nut. All kinds of nuts like a square nut, hex nut, wing nut, floating nut, coupling nut, and some special T nuts, four-pro T nuts, rivet nuts, nerd nuts. This one is a hex nut. Hex nut, yes, that's it. Made of carbon steel, and the surface is inclusive. This is brass. No, the brass nut material is brass. The alloy of carbon or alloy of copper and zinc, brass, and the surface is not. The cylindrical surface is not. So it will increase the friction, and you can do it by hand very easily. For this nut, actually there are uh, seven different sizes, and one machine can we have developed one machine to inspect all the seven different sizes of nut nut. Okay. This one it's a rivet nut with half hex here and a flange. here around the bottom range. And the material is carbon steel, and the surface finish is color galvanizing, color decorating. Another book is this. Let's see. This is a screw. It's a self screw. Screw like timber screws, sheet metal screws, drywall screws, lag screws. It's heavy duty screws. Usually, no, the head type usually the head type is well accepted. They 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 wrench instead of a screwdriver. There's heavy duty lag screw and some pocketed screws, and the set screws. Okay, for screws, this one is self-typing screw with pointed end, and the head type is flat head. Well, the drive type is Phillips drive. So this is another screw. It's very long. This one, length is 250 millimeters. This screw is surface finish is acrylic, special coating. Has good performance in corrosion resistance. The head is this head shape is pan head, round head, and the socket is the strap type is hook strap. Okay, this thread is 1/3 of the total length. For this thread, we have a machine to inspect the uh, 7 different sizes of this kind of screw. There's 7 different sizes from 100 millimeters to 250 millimeters. 7 sizes inspected by one of our machine, one set of our machine. So the compatibility is very good. This is a very long screw, timber screw. Besides that, this one, rivet. This is a rivet, self brand rivet, or you may call it self-tapping rivet. The core of the rivet is made of steel, but the jacket here is made of aluminum. Okay, for this part, the position stand on the work table is random, so it's difficult. In that case, it's difficult to make the thoroughly inspection of the part. You can not easy to check all around the part, the entire surface of the part. So we adopted slotted disc, slotted steel, steel, slotted dial made of steel. The part will be there are slots all around the steel dial, and the part can be fixed properly all around the steel dial. So we can make the inspection. We can inspecting thoroughly all around the part. This is also a rivet. We call it tubular. There is a hole in the middle. It's made of aluminum. We call it tubular rivet. Besides that, another very large group of fastener is washer. This one is plain washer, or we call it flat washer. It's made of carbon. Besides that, fender washers, lock washers, spring washers, internal ring, internal tooth lock washer, external tooth lock washer, and the sealing washer. It's a combination of two parts. One side is steel, the other side is rubber. Okay, this is the plain washer made of steel, carbon steel, and the surface is galvanized zinc plating, or we call it zinc plating. This one is also screen. It's a screen washer, a screen washer. It's also a washer, screen washer. You may call it a straight ring lock washer. Okay, the surface is color galvanized. This one is similar like a washer, but actually it's a retaining ring. Retaining ring. It's a external retaining ring used to fix the machine elements or shaft. Yes, retaining ring made of steel, and the surface finish is black oxide coating. Another group is this. This is a stamped part. It's a shallow ball-shaped cover used in automobile industry. This part, you can see, is made of steel and surface is galvanized. The difficulty is that there are 19 different sizes, same shape, different sizes should be inserted. There is no need. I think it's not feasible to develop 19 sets of machine. It's very inefficient. It's inefficient. So we developed one machine. Yes, only one machine. We inserted 19 different sizes. That way, 19 different sizes, shallow ball shape cover for automobile. Okay, besides that, this one is also a stamped part. It's a irregular stamped part. For this part, we can also make the automated inspection. If you have similar parts, don't worry. Send us samples. We'll make a proposal for you. We can insert any kinds of irregular stamped parts. Of course, some parts may not. May too special. Some parts may not. May cannot be inspected automatically because the shape is quite unique, quite strange. But we quite special. But we can make analysis first and give you a proposal, provide you a proposal. Okay. Another group is pin. This is a door pin, or you may call it a handy pin. It's very simple. It's a cylinder. Yes, chamfers, two side chamfers. Other pins like quarter pins, rim pins, taper pins. Yes, and some special pins like this. This is a non-standard part. It's a machine pin. One side is flat, the other side is a brand hole, and there is a through hole, very small through hole comes through one side of the part. This part, we also one of our machine can inspect this part. The machine is still in development stage, and the machine is done at one corner of our factory. I think I can introduce them to you next time. Okay? Is that okay? That the stamped part, a regular stamped part. Here, this one. This one. Bearing. Bearing. This is a ball bearing. Bearing, ball bearing, needle bearing, roller bearing, uh, angular contact ball bearing. Yes, we can insert also small bearing. The bearing, like this, or this one, very tiny one. You can see, very tiny bearing. For, for very tiny ball bearings like this, it's very difficult to observe them by human eyes. And we developed the machine, one of our machines, can insert very tiny rod, very tiny imperfection on the surface of the ball bearing, or very small bearing on this. And we, our machines have 9 workstations, and we can inspect 20 items. 20 items include rust on the surface, the dent, the scratch, the burn, and the dent on the retainer cage, on the retainer cage, retainer, and the deformation of retainer, and the meeting, while the meeting the board, the meeting of board. Okay, ball bearing, very tiny ball bearing. And we also embedded the AI deep learning algorithm, so we can achieve 100% good judgment. We can achieve zero misjudgment. There is no risk that the part may be defected as good one, the defective one judged as good one, and slip through. That part is this. It's a made of wood. It's a wood pin. Or the cylindrical surface is not. This is a plastic part. We can also inspect the non-metal parts. Non-metal parts, wood, plastic, or rubber, rubber ring, rubber or ring, something like that can be also inspected by us. Plastic cover, plastic bush, this one plastic, like the interpreting like the fresh electrical material, yes, and the information, and things like that. This one is a barber. It's a barber. It's a barber fitting. Some other fittings or couplings also can be inspected. This type of barber fitting, one of our machines can inspect 7 different sizes and shapes. Some are, this one is color demonstrated, and some are black oxide coating. All can be inspected by one machine. Okay, these are the typical parts which can be inspected by our machine. If you have any questions, please comment on here. Thank you. Now, I have introduced some these typical parts which can be inspected by our machine. Now, next page, I would like to introduce what are the typical items, what are the dimensions can be measured by our machine, what are the appearance effects can be observed by our machine. So welcome our next friend. This is Howard with open next. I'm your host today. Right now, I'm in Shanghai factory, which is about 25 minutes from Hongqiao Airport. And I would like to introduce optical sewing machine or fastener inspection machine. So, what are these items can be inspected by our machine? First, diameter. The diameter, the diameter of the major diameter, the largest diameter of the thread, the minor diameter, the smallest diameter of the thread, the head, the head diameter, the pitch diameter. The pitch diameter is the diameter of an imaginary cylinder where uh, the width of the thread and the width of the space is equal. Thread pitch equal to T diameter. The diameter of the washer, inner diameter, outer diameter, diameter of the bearing, diameter of the outer waist and the inner waist, the diameter of the screw, the head, the nut, the thread, the diameter of the hole. Okay, this is about speaking. The diameter of the inner and outer, yes. The diameter of the coat and the jacket or brand label. Okay, that the height, or you may call it the thickness, the total length, the height of the head, the height of the thread, the length of the thread, the length of the pin, the height of the nut, and the distance from object edge and the object angle, the distance. This one is quite unique. This one, the double figure. It has several stages. Here, several stages. We can measure each stage. We can measure each stage, the height of each stage, the height of each stage instantly at the same time, simultaneously at the same time. This one, the whole, the very long spool, the whole total length, the height of this one, the height here, the screen washer, and the initial height of the screen washer here. Open, there's opening. The initial height of the screen washer is very important because the initial height determines the initial force of a screen washer. And the screen washer, the initial force will serve, will function anti-load. If the initial force is not correct, the function, the anti-load cannot be properly functioned. Okay. For irregular paths like this, irregular stand paths, the dimensions are determined. Which dimensions in which dimensions to be made are determined by the user, by the customer. We can make calculations according to the requirements and inspect all the critical dimensions for you. The height of this relative map. Okay, I will introduce the parts. All the critical dimensions can be made by our machine. Besides that, there are another group is which is also very important, which also should be measured, that is the appearance, the appearance, such as the damage of the thread, the continuity of this thread, no matter external thread or internal thread, the problem of the thread, they close on the surface, they bend on the surface, they crack very tiny flaw of the head, of the both head. This can also be inspected by us. They rust on the surface of the ball bearing. They burn on the surface, on the edge, at the edge. They burn at the edge and because at one side, because the washer is usually stamped hard. It's made of by stamping dies and punch. So usually there's one side is sharp, the other side is round. For the sharp side, sometimes there may be defects like burns. These burns can be inspected by our optical machine, by our fastener inspection machine. This one, recently, we can measure, and this one is dichromatic. The surface finish is dichromatic. For dichromatic, uh, there may be some coating problem, so the coating is not good. The defective, the coating defective can also be inspected and observed by us. The scratch on the surface, the damage of the thread inside. Besides that, our machine also has the OCR function. OCR means optical recognition, optical character recognition, OCR. So the letter stamped on the surface, of both can be observed, can be inspected by our machine. We can separate them according to the stamped letters. As you can see, the stamped letters on our board, usually on land, usually indicate the grade, the correct grade of the board. We can separate them according to the stamped letters. And also you can see the part number on the surface of bearing. We can also separate them according to the stamped letters. Okay, besides that, OCR function. Besides that, we can also measure the geometrical tolerances. That's the brightness of the washer, the consistency of the internal and external circle, the consistency, and also the security or the roundness of the circle, roundness of the shadow function cover. That the straightening for very long time like this is also important. Very long, 250 meter long uh, screws with dichromatic surface, dichromatic finish coating. The straightening we can check the finish. Make sure the straightening are within the tolerance. Okay, so these are the typical interesting items we can take, we can check, we can observe. Some items are not mentioned in this lecture. Just to give me your feedback, and I will check. I think I will give you the time. We will check whether they can be inspected by us or not. Uh, or we can inspect it, in fact, we can inspect it many kinds of imperfection, not limited by not much more than what we have the atoms we can inspect are much more than what I have just mentioned. Okay, so we can inspect a lot of imperfection. So we can make sure the parts inspected by us, sorted by us, are good and guaranteed because they are guaranteed. Okay, so now I have already introduced the structure of our machine, the parts, the detectable parts, which parts can be inspected by our machine, and the physical inspection items, the dimensions, the geometrical tolerance, the appearance, and the OCR. Now I would like to say, I would like to answer some frequently asked questions. I would like to answer if a clue. Some people ask first. Some people ask, what is the uh, what is the guarantee of your machine? Usually, our guarantee is 1 year. Yes, we have make our machines are made of high tech parts, high grade, high quality components. The top, the PLC, the computer, the camera, the lenses, and the sensors. These are all of them are high quality parts. Some famous brands like SMC, Siemens, like Pin, like Mitsubishi, yes, like Blaster and Computer. They are all famous brands and we adopt this part, so our quality is guaranteed. The second question is what the speed, what the cycle time we can achieve. The speed we can achieve is maybe the maximum speed we can achieve is 1,000 pieces or even higher than that, 1,000 pieces per minute. This depends. This speed largely depends on the size, on the shape of the part, of the part. Usually, if the part is small, the speed is higher. If the part is bigger, the speed is lower. Because the bottleneck of our machine usually is the feeding system, is the feeder. Our inspection stations are based on the optical technology, based on the machine vision technology. So the inspection is non-contact, non-destructive. So the speed is very high. The speed is more than 1,000 pixels per minute. But the feeding speed you cannot be so high. So the bottom line is feeding. The maximum speed we can achieve is 1,000 pieces or more than that. For both, for middle-sized boats or not, the speed is usually a few hundred pieces per minute, maybe 200, maybe 500, and that. Okay. The third question is, uh, we are not sure whether you can invent our machine or not. How can you make a suggestion? Okay. In that case, I suggest you can send me some pictures, some drawings to me. And after that, you can send me a few samples. We only need a few samples, and we can make an analysis. We can give you a proposal free. In the proposal, we give you will provide you, will make a proposal for you freely. In the proposal, we'll tell you what is the speed we can achieve, what are the workstations, what are the lenses, what are the light sources, what are the cameras of each workstation, and some details, technical details, and the speed, that's the what kind of defects, how, what are the defects, what are what are the functions of each workstation, and so on. So we'll tell you all the details, and you can make a decision later after after the receipt of our proposal. Okay. The fourth question is, uh, uh, have you any already send your machines sell sell your machines to outside China? Have you already some global customers? The answer is yes. We already exported many machines to other countries. We such as some other such as our machines are exported to China, to Japan, Thailand, Italy, Vietnam, and England. Yes, we maybe at present we most of our customers are domestic. We already introduced it. We already started the marketing. Already marketing. We exported many parts to many companies abroad. To many companies abroad. Many we are a global company. Yes. So there's no further. The basic problem is how to avoid how to avoid misjudgment. It's a good question. If misjudgment is a good problem, is a big problem for making the investment. If they pass misjudged, then maybe cause big trouble, especially when they effective pass just like everyone. They effective pass still through and deliver to the end user, it will make big trouble. How to avoid that? We invest AI in learning algorithm. How does AI work? How does this learning algorithm work? We train, we first we mark the mix the pictures. We select the pictures and we mark the pictures, mark the detected areas, and then we train the machine. We train the machine many times. That the machine will learn how to make correct judgment. So we will verify the judgment, and finally we will make sure the machine can make the system can make correct judgment. So we can achieve zero misjudgment, and there is no risk that the first part, the effective part may slip through. Okay. Hi guys, welcome to our live stream. This is Howard with Open Next Group. I'm your host today, and if you have any questions, just comment down here, and I will give you reply immediately. And right now, I'm in Shanghai factory. This is about 25 minutes from Hongqiao Airport. Okay, below me is one of our machines, and I have already introduced the instruction, the application of our machine, the inspection items of our machine. So I think we already on live stream is well advanced 1 hour. Please let me make a summary. I would like to emphasize the advantages, the benefits of our machine. First, accuracy. Second, accuracy, efficiency, and consistency. Accuracy. We can achieve accuracy up to 0.01 millimeters. That is 10 micron or 1% millimeters. Very tiny, very tiny size. And based on the optical, maybe the optical effective technology, AOI technology, we can achieve non-contact, non-destructive inspection of 100% automated non-contact, non-destructive inspection. So there is no risk that the part may be damaged during the process. Okay. The second efficiency. The efficiency with speed of our machine can reach up to 1,000 pieces or even higher than that, 1,000 pieces per minute or even higher. There is a case. One of our customers purchased one set of our machine to inspect their boat to the boat the manufacturer. And the result is that this is 5 to 6 operators, 5 to 6 operators, which are formally previously these 5 to 6 operators are will to observe, will to check recorded by human eye. Okay, they record the 5 to 6 operators in 1 year is about 2 times. 2 times the price of one Tesla machine. In other words, the investment, the purchase, the investment can be recovered in half a year. Yes, ROI is half a year. So we can improve your price and reduce your manufacturing cost at the same time. The third is consistency. The judgment made by our machine is based on user-defined, accepted, and rejected fragile. User-defined, accepted, and rejected fragile. So once the fragile is set, the machine will make the same judgment again and again. Okay, that is consistency. Besides that, on the comparison, the operators, they check the code, the appearance code, the human they make judgment. The judgment is subjective and inconsistent. Maybe they judge it as good one this time, and they judge it as bad one next time. So that's we may call maybe big trouble. We call big trouble. A, that is consistency. That we can also embed the AI engineering algorithm to our system. We also, of course, will improve the hardware, will improve the industrial PC, improving hybrid graphical card is required. Both software and hardware will be improved. In that case, we can achieve, we can observe very tiny flaws, very tiny imperfections of the task, and we can achieve zero misjudgment with the help of our AI dictionary algorithm. So, for such as the goals, of the goals, the discontinuity, the damage of the thread, the crack of the head, this tiny flaws of the head, this tiny flaws, this tiny imperfection, traditional methods is cannot manage to infect them. Traditional method is useless, but our AI learning algorithm can observe that, and we can achieve 100% correctly infection. We can achieve zero judgment. So there's no risk that the defective part may come through, may slip through, and deliver to the end user. There's no risk that the more problem cause big trouble. Our machine can eliminate such kind of risk. Our machine can improve your quality and reduce your manufacturing cost. Our strength is accuracy, efficiency, and consistency. Hi guys, welcome to our live stream. So that is the end of our live stream today. I will see you next time. Have a nice day. Bye bye. Bye.